Hello everyone, welcome to my project presentation. I am Sudarshan Marke from Department of Computer Science and Engineering from Savitha Engineering College. Today, I'll be presenting my final year project AquaPredict, an AI-driven fisheries prediction and market analytics system for sustainable fishing, guided by my mentor Malati ma'am. In this presentation, I will cover the introduction, problem statement, scope, methodology, system architecture, UML diagrams, algorithms used, implementation, results, conclusion, and future work. AquaPredict is an AI-powered system designed to support fishermen, traders, and aquaculture planners to making data-driven and sustainable fishing decisions. Traditional fishing heavily depends on experience and guesswork, which leads to fuel wastage, safety risks, and income uncertainty. Our system solves this by analyzing environmental factors like temperature, salinity, oxygen levels, wave heights, and seasonal patterns, along with historical market price data. The platform provides prediction, dashboards, heat maps, and AI-based recommendations to improve safety, profitability, and sustainability. Fishing operations face major challenges due to the absence of an integrated decision support system. Fishermen struggle with unpredictable weather, difficulty in predicting fish availability, and unstable market price. The objective of AquaPredict is to build an AI-driven system that combines environmental, biological, and economical data to provide accurate predictions and actionable insights. The scope of this project includes fish species prediction using machine learning, market trend analysis, environmental safety monitoring, and sustainability awareness plan. The target users are fishermen, fisheries department, and seafood traders and coastal planners. We use publicly available environmental, weather, tidal, and historical market datasets. Advanced ML models like random forest are used. However, the system does not cover all global fish species and does not use real-time satellite sensors, which is considered a limitation. The methodology starts with data collection from environmental and market sources. The data is cleaned, normalized, and encoded before training the model. A random classifier is trained using parameters like region, seasons, temperature, salinity, and oxygen levels. So the trained ML model is deployed using a Flask API, Node.js, and Express managed chatbot environmental services. A React-based front-end displays prediction, dashboard charts, and heat map. The system is tested for accuracy, reliability, and usability. And the core algorithm used in this is the random forest classifier. It chooses it is chosen because it handles mixed data types, reduces overfitting, and captures complex marine patterns effectively. Along with classification, a probability-based ranking mechanism is used. Fish species are ranked based on occurrence probability and combined with market price trends to recommend the most profitable species. Uh, so, AquaPredict is implemented as a full stack AI application. ML models are trained in Python, developed via Flask, and accessed through a React frontend. The chatbot integrates external AI and weather APIs for real-time assistance. And the rest of the slides I would scroll through where it will be shown for important code segments and APIs and stuff. So these are the output pages including dashboard, fish predictor, market trends, environments, chatbots, and the harvest planner. Each page provides actionable insights for users. Uh, and the system is tested using multiple scenarios to validate prediction accuracy and system stability. The model has achieved an accuracy of around 78 to 80% with a strong precision and recall. The results show reliable predictions and meaningful recommendations for a real-world fishing. So, AquaPredict successfully demonstrates how AI can modernize traditional fishing practices by integrating prediction, analytics, and AI assistance. The system supports safer, smarter, and sustainable fishing decisions. As part of the future enhancements include real-time satellites, data integration, deep learning models, GPS-based route optimization, multilingual chatbot support, and mobile app deployment. Thank you. We can proceed with our demo. Our dashboard serves as the mission control. The UI is built using React and Tailwind, focusing on high contrast dark mode for better visibility in outdoor maritime environments. Uh, the philosophy is built on three pillars: harvest guidance, safety awareness, and what sustainability. Our sidebar remains locked, ensuring that whether a user is checking a market trends or whether the core navigation is always one click away. The fish prediction module is where our machine learning models live. In advanced mode, we empower researchers and commercial operators to tweak normal environmental parameters like salinity, temperature, and dissolved oxygen. These inputs feed into our Python class-based ML service, which runs inference against historical migration patterns. Sorry. For the everyday fisherman, we have a simple mode. This abstracts the complexity away by simply selecting the location like a coast, and the system uses a seasonal heuristics to predict the most likely species in this case, like a certain fish with a confidence score. Uh, the visual hat here is the interactive heat map, which is built using the leaflet. Uh, it uses cluster-based visualization to show high concentration, and this reduces the search time at sea, directly cutting down the carbon emissions and fuel costs. Success isn't just about catching fish, it's about the economics of the trip. The harvest planning used is a unique feature that acts as a pre-voyage business case. User inputs their logistic vessel count, gear type, and fuel price. Then the AI generates a trip economic summary. Like here, it recommends the targeting mackerel in Mumbai and forecasting a net profit of 5 lakh and after a 30k fuel detection. Notice the risk assessment tag. If the ML model detects a low confidence scenario, it triggers a rule based fallback, ensuring the user is never left without a guidance while clearly labeling the data source for transparency. Um, like market trends and environments, here we are catching fish is the only half of the battle, and selling them at the right price is the other one. Our commercial analytics module tracks the real time volatility. We feature a price trend analysis graph for the top tier species like tuna alongside gainers and losers list. Directly integrated here is our nearby buyers directory and tied with the telemetry. By seeing that the high tide is expected at a certain time alongside a certain wave height, the captain can decide if it is safe to dock at a port or if he could wait for better conditions. Finally, we recognize that not every user wants to navigate charts. AquaBot is an maritime assistant. Using a dual engine approach, Gemini for complex reasoning and Croak for high speed fallbacks, AquaBot answers natural language questions like what can I catch today? It doesn't give a list, it provides a contextual advice on gear, bait, safety. This lowers the barrier to entry for knowledge, accessible to anyone with a smartphone. Technically, AquaPredict is just a robust application, and for front end, I have used React for a responsive UI, and backend is like Node.js and Express handling API orchestration, and Python Flask and Gemini API for predictive modeling. We reduce economic uncertainty, increasing safety, and most importantly, we promote sustainability first by preventing overharvesting through date-backed limits. AquaPredict is not just a tool, it is a bridge between the ocean and the digital age. It is about ensuring that the fishing industry remains profitable today without sacrificing the ecosystem of tomorrow. Thank you for your time.